everyone, today we're going to do 14.3, evaluating and graphing piecewise functions. And this is the part that I think is definitely going to be asked. And it's pretty easy, so we should be good to go. Okay, so if you look at this first function, there's two parts to it. So it's one piece and the other piece. And the first piece says the equation is f of x equals 4. And we only use this one if x is less than or equal to 0. And then it says f of x is 0, and that is if x is greater than 0. Okay, so first I look at here, I'm trying to find what f of 2 is. Well, I first have to determine which equation am I going to use. Well, 2 is greater than 0, so I'm going to use this equation right here. And so if 2 is greater than 0, then it says f of x equals 0. So my answer is 0. Let's look at this one. We're going to find f of negative 4. So negative 4 is less than 0. So I'm going to use this equation, which just says my answer is 4. So the main key about this is figuring out which equation to use. F of 0. Well, they both have zeros here, but this one has equal to. So it means my answer is going to be 4. Down here, f of negative 2. Negative 2 is less than 0, so my answer is going to be 4. Okay, so then we're going to look at the next equation, next function, g of x. So the f of x and g of x is just a different way to call it, so you know which one I'm talking about. So if you were looking at this page and I said g of x, your eyes would automatically draw here, and you know I'm talking about. This is just a way to identify which equation I'm talking about. So it says down here, g of x is where x plus 3, that's the equation I'm going to use, g of x equals 2x plus 1. And so I use the top one if x is less than or equal to 3, and I use the bottom one if x is greater than 3. All right, so they want me to find f of 3. Well, which equation am I going to use? I'm going to use this one because this says equal to. So now I have to plug the 3 into the x. So I guess I should have had g's here. Sorry about that. Fix that real quick. Whoop. Okay, so I'm trying to find g of 3. Sorry. I plug it into this equation, so 3 plus 3 is 6. G of negative 4. Well, which equation am I going to use? Negative 4 is smaller than 3, so I'm going to use this equation. Negative 4 plus 3 gets me negative 1. G of 0. 0 is less than 3. Oh my gosh, you guys, all of these are less than 3. Let me change this one to maybe 6. Okay, plug it in here. 0 plus 3 equals 3. G of 6. 6 is greater than 3, so I'm going to plug a 6 into here. 6 times 2 is 12. 12 plus 1 is 13. All right, hopefully I did not do the same thing down here. All right, so now this is a piecewise function that has 3 separate pieces. All right, but I'm going to do the same exact thing. So negative 4. My sections here are less than negative 2, between negative 2 and 1, and greater than 1, okay? So I have negative 4. Negative 4 is less than negative 2, so I'm going to plug it into here. Negative 4, a half of negative 4 is negative 2. Negative 2 plus 1 is negative 1. Plug a 2 in here. Well, 2 is greater than 1, so I'm going to use this equation down here. I plug the 2 into the x spot. 2 times 2 is 4. 4 minus 1 is 3. 0. 0 is this midsection right here. 0 is between negative 2 and 1. So I'm going to plug it into here. 0 minus 2 is negative 2. And 1. So I have 1 here and here, but this one says equal to. So I'm going to use the bottom equation, plug a 1 into this part. 2 times 1 is 2. 2 minus 1 is 1. All right, so that's using the piecewise function when I'm just evaluating it, which you just find which domain it fits into and then plug it in and get the new range. All right, the next thing is graphing piecewise function. So this has a little bit of both. This has, first I'm gonna show you how to do the graph of this, and then from the graph, we're gonna answer these questions. Now, once again, if this was a standardized test where they just wanted you to get the answers and they weren't looking at your graph, then you could just go from here and figure out where your 3 would go and plug it in. You can always do the method we just did, but I just want to show you how to graph them. Okay, so the first thing I do is I'm going to draw my X and Y axis. And then I like to just say, okay, great. Okay, let me just do a little sketch of this. So, it's like y equals mx plus b. My y-intercept is 5. 1, 2, 3, 4, 5. And my slope is 1. So I know my line goes like this. And so now I have a little picture in my mind. Now this is the only time I can use this is where x is less than -2. All right, so basically I have to erase all of this until I get to where x is -2. So this is where it's going to start, and I just follow it down like this. Okay, so what I did is I ignored this. I ignored my domain for a second. I drew a sketch of my function, and then I just figured out, where does my domain pick up? It picks up where x is less than -2. All right. You could also plug in. You could plug in -2 here and get -2 plus 5 is 3. So it's -2, 3. And then you maybe could have plugged a 0 in. 0 plus 5. Oh, no, I don't want to plug a 0 in because 0 is not less than -2. Sorry. I could plug a -5 in. -5 plus 5 is 0. So at -5, I'm at 0, and you could connect. You could also do it that way. All right, so let's go back here. So now I have to do this part. Well, I'm going to draw a little sketch again. My y-intercept is -1, and my slope is -2. Okay, so I have this going, and I'm going to use this where x is greater than -2. So that is my piecewise function. This piece here is the top part, and then over here it's the bottom equation. Okay? Let's look at, so now we could just answer these questions. F of 3. Well, at 3, 1, 2, 3. Whoops, I guess I should have kept going here. At 1, 2, 3, my answer is 1, 2, 3, 4, 5, 6, 7, -7. Same thing would have happened if I plugged a 3 in here, right? -2 times -3 is -6. -6 minus 1 is -7. But since I have the graph, it's pretty easy to do this. 1, 2, 3, 4, 1. 1, 2, 1, 2, 3. All right, let's go to this last one here. So once again, I'm going to graph this function. My y-intercept is 1, and my slope is 2. So I'm going like this. Just draw a really light sketch of it. And then let's see what the domain is. I'm going to use this function when x is greater than 1. Okay, so should have had a little more room maybe. So where x is greater than 1. So I'm going to put an open circle here because it's not underlined. Like, I mean, it's not, oh, it is underlined. So I am going to put a closed circle there, sorry. So since that's underlined, I know at 1 it's including. And then I'm going to do a sketch here, -3. And my slope is 1/2. And let's see what the domain is. I'm going to use this when x is less than 1. Okay, well, this is where x is 2, so I'm not going to use it here. And I'm going to have an open circle here. So it starts here, and it's going this way. So that is what my function is going to look like, my piecewise function. So you have 2 different sections. And now I can answer these questions. F of -2, well, at -2, 1, 2, 3, I'm at -4. At 0, I'm at -3. And at 1, well, which one am I going to use? The one that had the solid dot, because I'm including 1. This would not be included here. So I'm going to get 3. All right, so that's a pretty easy way to look at it. That's how I like to graph my piecewise functions and just evaluate them. All right, bye-bye.